So, good morning, everyone, and thank you for the invitation and the opportunity to present here. My name is Juan Gutiérrez. I'm a radiologist, and I currently work as the medical lead for the digital radiology business of Bayer in the EMEA region. And we are, for the last 2 years, promoting the implementation of an AI vendor-neutral platform for AI in radiology. Today, I will present you some learnings that we have been experienced regarding the implementation of AI in clinical practice. But before start, I would like to know how many of you here consider yourselves that have a decent knowledge on AI? 1, 2, 3, 4, 5. Okay. I think it's I always do the same question, and we are in the same level. How many of you are radiologists in the room? Is there any radiologists in this room? Okay, so I'm the only one. Okay. So, this is not working. 1 second. That's the thing, we need it. Okay, thank you so much. Okay, so to start the presentation, I want to focus on two topics that are quite relevant. First one, the availability of AI technology, and the second one, on expectations. Regarding availability, I think it's important to know that in the last 5 years, we have experienced an almost exponential increase on the number of available CE mark AI solutions in Europe. This means that are clear to be used in clinical practice by the European Union, as we can see in the graph. I know that this one is from 2019, so it's not so updated. So for that reason, I bring this other one provided by the FDA last year. And this is the list of authorized AI-enabled devices by specialty. As you can see, radiology lead by far. Currently in the US, there are more than 500 AI applications clear to be used in clinical practice. The second idea regarding expectations. We are seeing a survey conducted and published in European Radiology in 2021 to more than 1,000 radiologists from 50 different countries. As you can see in the first graph, the majority of them believed or expressed their belief that AI will improve diagnostic radiology, and for sure that AI will alter or change the future of radiology. When they were asked how, the first answer was acting as a second reader, as a second pair of eyes, helping you to read the images. And the second most frequent question was workflow optimizations, so to helping us to be more efficient in the way we read cases and provide a report. The number of people answering partial replacement or total replacement of AI, it's decreasing over time. And this is quite funny because at the beginning, this was one of the fears that many radiologists expressed, that we were going to be replaced by AI. But nevertheless, that we have more than 500 applications in the US and 200 applications in Europe. And nevertheless, the fact that the expectations to the deployment and use of AI are quite high in the radiological community, the reality is that the implementation is lagging. We have two surveys here. The first one conducted by the American College of Radiologists in 2020 that demonstrate that 66% of them are not using AI in the practice. And the second one conducted by the European Society of Radiology, in which they demonstrate that 60% of the clinicians have lower. So when you start reviewing the literature to try to understand why the AI adoption has been so slow, you realize that it is a multifactorial problem and that there are multiple barriers. For the purposes of these presentations, I organized them in pre-implementation, implementation, and post-implementation barriers. On pre-implementation, something that is quite interesting is that we are lacking good data quality and label data. And this is crucial because we need high level or high quality label data to train the algorithms. And the majority of people is not aware about the fact that this type of data is quite rare. Another problem that we have, that we're going to review in an following slide, is the lack of evidence. We have seen some improvements in the last years, but we're still far behind what we need to provide enough trust to the users on the use of AI. Regarding benchmarking, if you have more than 200 applications to choose, imagine that you have 10 applications for the same problem. How to choose? Which one is better? We are not being, the majority of the physicians, for sure, I was not trained during my fellowship, we are not trained to compare and understand which application is better than the other. And that is a problem. Actually, we are developing a publication these days, and the amount of human and economical resources required to properly benchmark an AI solution, it's way higher than expected. Finally, economics. Who and how we pay for AI. Should we pay for AI? Should be free? At an implementation level, we have scalability. We know, because we have been doing this for the last 2 years, that implementing one application takes between 6 to 12 months. But if you want 10, we're going to need 12 years, 10 years? No, but you're going to require more human resources and economical resources, and there's another problem. And we also have workflow disruptions. If you incorporate a new step on a current workflow, we need to be secure, or we need to be sure, that we have a seamless integration, because if not, we're going to create a disruption in the workflow, and that disruption means time, and that times mean no adoption. And finally, we have interoperability. We have multiple solutions, multiple software and hardwares that need to communicate between each others. And it seems impressive, but that step is not yet completely solved. We have problems communicating the different softwares and hardwares that work on radiology. At a post-implementation level, I just want to mention for a moment monitoring. Monitoring is the trend now. If you go to an AI congress or an radiology congress, half of the AI presentations are going to be around monitoring. The majority of the countries in the region are developing legislations to secure the monitoring of AI. The graph, it's quite interesting because you notice that depending on the level of knowledge that you have on AI, your perceptions of the barrier change. And at the end, I think this is a really good example of something that all of us already know, that education is the key. You need to be aware of the capabilities and realities of any solution or any technology or everything at the end to fully understand how to use it and what are going to be the barriers. So in the upcoming slides, I just want to focus on a few topics that I think from a medical perspective are important. The first one is related to clinical needs, and it's the concept of AI use case. An AI use case is basically the scenario in which an AI is going to be used. I'm a radiologist, so I will not move from here, but for us, an example is going to be large vessel occlusion detection, that at the end is the detection of a stroke, or the detection of nodules in the lung that can be cancer. The identification of these use cases, of this context, is quite important, and the physicians will play a pivotal role here, because these cases at the end reflect the pain points and the problems that we face in our daily work. And this may sound impressive, but up to date, many of the solutions available in the market were not designed considering the use cases, were designed focusing on the available data. So after many years and a lot of money spent creating a solution, the developers and vendors came to hospitals saying, this is the best solution. And when physicians start using them, it was like, yeah, but this is not, makes no sense to us. This is not giving us any information. It's not being adopted in our current workflow in a proper way. So for me, it's a little bit shocking because you are not aware of the amount of money that vendors have invested in solutions that were made for problems that don't exist. The image, it's a really interesting project by the American College of Radiologists. They are creating a repository of clinical use cases for AI. And in this repository, you will find information regarding the overview conditions, clinical implementations, datasets consideration needed to train an algorithm for a particular situation, technical specifications for the solution, and future developments considering the current guidelines and the future ones. This type of tool is extremely powerful because in one hand, provide incredibly important information to developers to at the end create solutions that are going to solve real problems. And on the other hand, these type of projects are really useful for physicians because they help us to identify better solutions. This is related to the benchmarking problems that I mentioned you before, how to choose. This is a first step to start assessing applications. Another concept that I want to focus today is on imaging AI governing bodies. Institutions that are considering to implement an AI solution should create a governing body because they need to develop a strategy and a framework to implement AI in a safe way, in a fair way, and effectively. According to literature, these teams need to be interdisciplinary. We need physicians, we need IT people, we need developers, we need data privacy officers to provide different points of view to the assessment of a solution. And these teams will have multiple objectives, like creating the guidelines to data access and system integration, to select the AI tools based on their clinical value and impact on the patient care, and assess the safety and effectiveness of AI algorithms in that particular institution. This is going to play a huge role. I don't know if you have been aware, but the European Council approved the AI Act 2 weeks ago and turns around risk and safety and correct use of data. So this is going to be quite important. Related to the previous slide, there are 3 things that I think are important to mention as for you to know. The first one is the data security risk. This is by far the first step that you need to address. At the moment that you have identified a solution that you want to assess and probably implement, you need to secure that the data security risk and data sharing processes during the entire assessment and implementation is secure, because this is commanded by law. The GDPR law requires this. Another thing that it's important, at least to know, is the local performance metrics. Imagine that a vendor come to you and explain you, I have this application and the performance is 99.9%. Okay, I believe you, but I implemented, and in my hospital, the performance is 89%. What happened with that 10%? It's not acceptable for me anymore. This is because there is a concept called generalizability, that is the capacity of a solution, of an AI, to provide good performance results when exposed for the first time to a new set of images. And these have not been published, to my knowledge, in the majority of solutions. And this is related to the third point, scientific evidence. We are still lacking a strong number of publications reviewing the performance of AI applications in clinical practice. A study conducted by Kiki van Leeuwen from the Netherlands in 2022, I think, studied 100 applications with a CE mark, meaning that the European Union accepts them to be used in clinical practice. 64 of them have 0 peer-reviewed clinical evidence about performance. 0, nothing. Everything was internal data from the vendors. As people working on healthcare, this is not acceptable. How on earth I'm going to deploy something that have never been tested? We don't have numbers. How I'm going to be responsible for the safety of my patients if I don't have strong data supporting these solutions? Multiple guidelines have been developed to assess and report the performance of an AI solution in different steps. We have them here. If any one of you is interested, we have guidelines for preclinical development, for early clinical validation, and for comparative prospective evaluation. Monitoring. Because of time, I'm going to be quite fast here, but we know that after an AI is implemented, the performance drops. And this is due to the model decay. And what is this? This is that because of the external context or ecosystem, if you want to put it, in which the algorithm is deployed change, the performance of the algorithm will also change. This can be demographics. This can be that we change an MRI machine, or that we have an upgrade on a solution. These things tend to affect the performance of the applications, and it's extremely important to control them during time. This example is a study where an application for triage pneumothorax was deployed in 4 sites. And after some time, the performance of the application drops. At the beginning, the investigators thought that it was related to the model drift. But after assessing the specific machine, they realized that it was due to a change of an upgrade of a software. This is extremely important. It's really easy to solve. Workflow integration. AI is going to touch the entire workflow of radiology, and we need to be aware that are going to be multiple use cases and multiple applications touching the entire workflow, and we need to avoid to have multiple workflows. I think I have a noise saying that I need to leave, so I will go to this last slide. Why all of this is important? Because of the promise of AI. The promise of AI is vast, and for sure it's going to change AI. This study, the Masai trial, was conducted in Sweden and demonstrated that applying AI to the breast cancer screening, they could reduce the workload related to the screening program by a half, without touching recall rates, without touching sensitivity, nor nothing. And this is extremely important. The results of the second round of the study were just presented in the ECR Congress in Vienna, and they already demonstrate an increase of 28% in the detection of breast cancer. Thank you so much.